Hello, today I'm going to be presenting my PR project, which is based on calorie estimation and healthiness determination using food image recognition. My name is Saurabh Mukesh Bhavsar and I'm a student at the University of Florida. I'm studying my master's in computer science. Okay, so the question of food, how important food is to our life? Probably the most important thing. And if you think about good food, what comes to your mind? It should be fresh, it should be tasting good, it should be locally sourced, but the most important thing, it should be healthy. Our food, the food that we eat contributes not just to our health, not just to our physical composition, but also to our state of mind. And in today's day of age, with so much stress around, food is vital. So what's the problem over here? You might be wondering, it's just food, right? Everybody eats. The problem is, not many people know how and what and when to eat. There are dietitians for that, there are doctors, there are researchers who specialize in all those studies, but I believe the common man doesn't have the time to reach out to them. And this kind of stressful lifestyle only piles on. So the challenge over here is knowing what to eat and not just eating healthy. It's like knowing what is healthy. And you can't just keep on tracking calories of each meal. One possible solution for this thing is to develop a system which identifies what kind of food are you eating and attempts to calculate calories that you will consume in that food. So even though there are many aspects to food and nutrition, but calories is like the most vital element of something that's healthy or not. So I believe a solution for this problem is to create a neural network based classifier, train it on a lot of images with different categories of food, and predict what type of food it is and calculate the calories. In this project, I have trained my classifier on 10 classes of food, and each of them had 1,000 images which were scraped from the internet, and they are part of a dataset which is known as Food 101 dataset. So as the process goes, we first train the classifier, identify the food, and determine basically if it's healthy or not by calculating its calories. There are a lot of solutions for this which are also available in the market. One of them is a very popular app which goes by the name of Calorie Mama. This app claims to predict the calories of food just by taking a snap of it of thousands of categories of food. But the thing is, these kind of apps are more inclined towards Western or continental cuisine and not for ethnic cuisine. So this project, my project, aims to emphasize on ethnic cuisine such as Indian food, Chinese food, Japanese food, Vietnamese food, because people in countries such as India are not that much technologically aware about food. Like you can play with technology and food together. So that is where this thing comes in. This project, although worked on limited data, is still pretty effective with an accuracy of more than 80%. And in some cases, when I ran it, it went close to 90% threshold. The conclusion for this project is like, if you train it on more number of images, implement it with better hardware, and increase number of classes, this project can go the distance. Now I will show you some of my code. So for this project, my inspiration was this project done by a GitHub user named Stratospark. It deals with food classification using Keras and TensorFlow, and it deals with 101 classes of the food 101 dataset. This project is very computationally intensive. Point being, you need a lot of hardware for this project. That's why I tried to reduce it to 10 classes, and the accuracy was still pretty good, keeping the number of images the same. So how I went through is, first I loaded and pre-processed my dataset on Google Colab. Then I split the dataset into training, validation, and testing. I created indexing for better mapping between labels and categories, and also implemented a package developed by Stratospark for randomly cropping patches out of images. Random cropping is done so as to increase the accuracy and reduce the chances of overfitting on the data. So this code does is like, it takes random patches of size 299 cross 299 from the images and uses them to classify. Now as we see, multiprocessing is used to just make the process faster. This is the model of the neural network, which uses inception model of Google's ImageNet, and it's already been trained on ImageNet before. This model gives me an accuracy of 91%. Which is also matched by Stratospark for their 101 classes classifier. And calories are calculated based on my Calories are calculated based on an online database from nutritionix.com. They are For this project, I've taken them per serving and mentioned the serving size also in grams. And the final metric for healthiness determination being used is calories per gram. And as you can see, there's a stark difference between some of the well-known rich food items which have a lot of oil or fats, and to healthy items such as salads or soups. The difference in calories per gram can be seen quite well. Yeah, and in conclusion, I would like to say that this project could have been made better with more resources, more data, and all in all, I'm very happy that I got a chance to work on such a good project. Thank you.